So right now I'm going to teach a topic called gravitation. What is gravitation? Gravitation is a force of attraction between every two objects having mass in the universe. Just like because of this gravitational force, apple falls downward. Because of this gravitational force, all the planets move around the sun. Because of this gravitational force, all the satellites move around the planets. So basically it is called a force of attraction, or rather universal force of attraction between every two objects having mass. So just like when you consider force between two charged particles like electron, proton, that time we consider electrostatic force. But whenever we consider big masses, we consider this gravitational force. So the basic concept of gravitational force was given by Sir Isaac Newton. All of you know that one day an apple fell on Newton's head and Newton got a clue that there must be a force of attraction due to which the apple falls downward. So after lots of research, Newton got this idea that there is a common force due to which all the planets move around the sun, apples fall downward, or all the satellites move around the planets. So from day by day research, Newton got a clue, and Newton got a mathematical formula of this force, that F equal to G m1 m2 divided by r square. What is m1 and m2? m1 and m2 are suppose two masses, 2 point masses. Here I have considered m1 and m2. m1 is the first mass and m2 is the second mass, and distance between them is r. r is the point to point distance or mass to mass distance. So look at the force F equal to G m1 m2 by r square. m1 is first mass, m2 is second mass. These two bodies are busy in pulling each other, and r is the separation between them. So if you consider a big mass, then also we will study the distance between two centers of these masses. So we can consider these big masses as point masses, and we consider the distance between these two centers. So that gravitational force is called a central force. There are few properties of gravitational force. This force is called central force. This force is called bidirectional force. This force is called weak force. This force is called conservative force. Few properties are there of this force. Why it is called central force? Because it is the center to center attraction. Just like I am standing, you are standing on the surface of Earth. That is due to the gravitational pull. So Earth is pulling us down towards the center. So not only Earth is pulling us down, but also we are at the same time pulling Earth towards our center. So basically it is a center to center force. Not only Earth is pulling the apple, but also apple is busy in pulling Earth. So both the two bodies are busy in pulling each other from one center to another. So that is called central force. It is called weak force because it's very easy to separate two masses from each other. Just like I already told that gravitational force is the force between two masses. So if I have this pen as a mass and this lid of the pen or cap of the pen another mass, these two bodies are also busy in pulling each other by this gravitational force. So very easily I can separate these two forces, two bodies from each other, but very easily it is not possible to separate the protons from neutrons. So proton and neutron, these nucleons experience a force called nuclear force, which is called a strong force, or rather the strongest force in the universe. Whereas when you consider force between masses or gravitational force, that will be a weak force. So that it is very easy to separate the masses from each other. So that it is called weak force. It is called bidirectional force because both the two bodies are busy in pulling each other. So if I draw arrow diagrams, it will be bidirectional. Look at this diagram. M1 is busy in pulling M2. M2 is at the same time busy in pulling M1. So both the two bodies are busy in pulling each other. So that is called bidirectional force, and it is called weak force, bidirectional force. These are the basic properties of gravitational force. Gravitational force follows inverse square law. Look at this, F equal to G m1 m2 by r square. So relation between r square and F is inverse square law. Once in WBCS that question was asked that which of the following forces is following inverse square law. So answer can be gravitational force because F and r square, they are inversely related to each other. So that is called inverse square. So that this force follows inverse square law. Now these are the basic properties of gravitational force. Again I am repeating. This is called weak force. This is called conservative force. This is called bidirectional force. This is called central force. These are all the basic properties of gravitational force. What is this G about? This G is called universal gravitational constant. The value of G is constant everywhere, so that is called universal gravitational constant. What is constant and what is constant and universal constant? Constant means it is constant for a particular case, but for different cases the value can be different. But what is universal constant? Universal constant means everywhere value of G is constant. Whether you are in Earth or you are in Jupiter or you are in Moon, wherever you are, value of capital G will be same everywhere. So what is the value of capital G? G equal to 6.67 into 10 to the power minus 11 Newton into meter square per kg square. That is the SI value or the international value of capital G. This value of capital G was not calculated by Newton. So many times that question is asked in exam, just like CGL, in WBCS. So many times that question have been asked, that which scientist calculated the value of capital G. Most of the students answered that value of capital G was calculated by Sir Isaac Newton, since the formula was given by Newton. But actually, before calculating the value of capital G, Newton expired. So after Newton, another scientist actually calculated the value of capital G. The name of the scientist who calculated the value of capital G is Henry Cavendish. Mr. Henry Cavendish is called as the man of hydrogen because he discovered hydrogen. So his name is found in chemistry as well as his name is found in physics also. So this man calculated the value of capital G, and that is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So look at the unit. From this unit, the question can be asked, what is the unit of capital G? What is the value of capital G? Which scientist calculated the value of capital G? This kind of questions can be asked in WBCS exam or in relevant exams. Okay, let's move on. Now, capital G has a mathematical dimension. How to write the mathematical dimension of capital G? Here I can write G equal to F R square by M1 into M2. G equal to F R square by M1 into M2, that we can write from this mathematical formula. So if I start writing the mathematical dimensions of F, R, M, it will be like as MLT minus 2 for force and L square for R square, and two masses are there, M square. So after cancellation it will become M inverse L3 T minus 2. Once in WBCS prelims that question is asked, that what is the mathematical dimension of capital G? So follow this. That can be asked, this unit can be asked. Okay, so value, unit and mathematical dimensions can be asked, okay, in exams. Fine. Now let me explain you a new topic called gravity. Rather you can say that it is a subtopic of gravitation. If gravitation is a universal force, then gravity will be example of this gravitation. Just like when you consider that the force between any two masses, then you will say that it is gravitational force. But when you consider the force between apple and earth, then it will be known as gravity. So basically gravity is called as the example of gravitational force. Just like apple falls downward, that is due to gravity. And already I said that this gravitational force is bidirectional force. Matlab, both the two bodies are busy in pulling each other, because Mr. Newton in his third law said that every action has equal opposite reaction. So the force by which earth is pulling the apple is same by which apple is pulling the earth. So these two forces are bidirectional and equal to each other. Now let me give you a mathematical formula of regarding this gravity. G equal to Gm divided by r square. G equal to Gm divided by r square. That's a mathematical formula based on this topic, gravity. What is this? This G is called acceleration due to gravity. What is acceleration due to gravity? Suppose you can see that in my hand there is a pen. If I release that pen from some height, it will fall down. It will fall down due to a force or due to the effect of a force called gravity. So any object falls down due to the effect of a force called gravity when you release this object. So whenever you release any object from some height, it has an acceleration. That is what is called acceleration due to gravity. So basically you can say that acceleration of a free falling body is called acceleration due to gravity, and that is represented by small g. In Newton's formula we have got a mathematical concept that F equal to m into a. Newton gave this formula of force in his second law, that F equal to m into a, and this formula can also be written as W equal to m into g. W equal to m into g. This W is weight of a body. Weight of a body means the force by which earth is pulling the body towards the center m is the mass of that corresponding body, and g is that acceleration due to gravity. That g can also be written like this: g equal to gm by r square, where m is the mass of the planet, r is the radius of the planet. This formula is valid. This formula is valid at the surface of a planet. Just like for Earth surface, you can consider this formula: g equal to gm by r square, where m is the mass of the Earth, r is the radius of the Earth. Okay, so that formula is valid at the surface of a planet or at the surface of Earth. But everywhere this formula is not valid. Just like already I told that capital G is universal gravitational constant, but small g is not universal gravitational constant. Small g is called a variable. Capital G and small g, these two are different. Let me say you this: g and g, these two are completely different. Capital G is called universal gravitational constant, and small g is called acceleration due to gravity. Small g is constant only at the surface of Earth, but when you move from Earth to any other planet, like if you move from Earth to Jupiter, if you move from Earth to Moon, wherever you move, the value of g will change. And on Earth's surface, from one point to another, if you move, value of small g will change, not the capital G, because capital G is universal constant, whereas small g is not universal constant, rather it's just a constant. Okay, constant only at a particular surface. Whenever you move from one point to another, capital G will not change, but small g will change. How small g changes? I'm going to show you this. Suppose I am showing a graphical representation. This is distance along x-axis, and this is g along y-axis. And this origin of the graph, all of you know that the coordinate of the origin is 0, 0. So at the origin of the graph, suppose I have considered center of Earth. Okay, and if I draw the graph between g and r, it will look like this. It will look like this. Look at the nature of the graph. And that point is our surface of Earth. Surface means where all of you belong. Just like if this is the center of Earth, that will be the surface of Earth. Suppose here I am standing. Okay, I am pulled by Earth by a force mg, and Earth is also pulled by me by the same force mg, because every action is equal opposite reaction. That force is the attraction force given by Earth on me, and that force is the attraction force given me on Earth. Okay, Acha. Now look at this graph. That point is the surface of Earth. That point and that point are same. Okay, in the graph, this surface is that particular surface in this diagram. So when you are at the center of Earth, g will be 0, because the coordinate of the origin is 0, and from the center towards the surface, if you move, value of g will increase. At the surface, g is maximum. From the surface, if you go right, that means from the surface, if you go up, value of g decreases. In this graph, if you are going left from the surface, that means you are going down from the surface. And if you are going right from the surface in this graph, that means you are going up from this surface in this diagram. So going up from this surface means g decreases. Going down from this surface means g decreases. That means when you are only at the surface of Earth, g is maximum. If you go up, g is less. If you go down, g is less. Look at the graph over here. At the surface, g is maximum, g max. From the surface, if height increases, g decreases, and from the surface, if depth increases, then also g decreases. That means we can say that only at the surface of Earth, g is maximum. Whenever you go up from the surface or whenever you go down from the surface, value of g will be less. So surface can be treated as a reference frame. And if you reach the center of Earth, g will be 0. That means according to height and according to depth, there is a mathematical formula. I can give you the mathematical formula. So with respect to altitude and with respect to depth, there are different mathematical formula. So for altitude, suppose I am giving the mathematical formula as g dashed by g equal to r square by r plus h whole square. And as per depth, I can give you the formula g dash equal to g into 1 minus d by r. Let me explain the formula now. Look at this, g dash by g or g prime by g. This g dash is the changed g at a certain height h from the surface of Earth, and this g is found on the surface of Earth. R is the radius of Earth and h is the height from the surface. Look at the relation, it is an inverse relation, isn't it? Because g and r square, general formula is g equal to gm by r square. So g and r square, they are inversely related to each other. So look at this formula, g dash by g equal to r square by r plus h whole square. That means the more is height, the less is g. And look at this, that d, look at this formula is regarding the depth. This d is called the depth from the surface of Earth. H is height from the surface of Earth and d is the depth from the surface of Earth. So following this and this equation, we can say that the more is the height from the surface of Earth, the more is the depth from the surface of Earth, g will be less. Only at the surface of Earth if you are, g will be maximum. Otherwise from the surface, if you go up, if you go down, g will be less. In that formula, if I consider d equal to r, can you say what will be the value of g? G prime equal to g into 1 minus 1. That means it will become 0. So when you can consider d equal to r, whenever you reach the center of Earth, you can consider d equal to r, because this d is called the depth, r is the radius of Earth. So from the surface, if you go towards the center, d and r will be equal. Then if you consider d equal to r, it will be 1 by 1, or it will be 1. So 1 minus 1 will give you 0. So at the center we can say that g equal to 0. At the surface, g is maximum. Now the point is, in Earth's surface there are two different points. One is called equatorial point and the other is called polar point. That means equator of Earth and pole of Earth. In these two places, equator and pole, g will be again different. So small g's are very sensitive. It is different at different places. At the surface of Earth, g is maximum. From the surface, if you go up, g is less. From the surface, if you go down, g is less. And in the surface of Earth, if you move from equator to pole, value of g will change. So at equator of Earth and at pole of Earth, g is different. How can you say this? Suppose, let me explain you. Earth is, all of you know that Earth is rotating from west to east. Okay, so Earth has a fixed axis of rotation. Around this, Earth is continuously moving. Okay, so as Earth is moving, Earth has a concept of rotational speed. The effect of rotational speed is maximum at equator and minimum at pole. The more is the effect of rotation, the less will be the value of g. Let me say you again, the more is the effect of rotation at equator, the less will be the value of g. That means we can say that g at pole is greater than g at equator. G at pole is greater than g at equator. At equator, effect of rotational speed of Earth is maximum, so that at equator the effect of centrifugation or centrifugal force is maximum. The more is the effect of centrifugation, the less will be the effect of gravity. So that at equator we find that g is less, and at pole we find that g is more, because at pole the effect of rotation is less. The less is the effect of rotation, the more is the gravity, and the more is the effect of rotation, the less is the gravity. So that at equator g is less, at pole g is more. So that we consider an average value at the surface of Earth, g average at Earth surface as 9.81 meter per second square. 9.81 meter per second square, that is called an average value of g on the surface of Earth. At pole, the value of g is more than this value. At equator, the value of g is less than this value. So that we have to consider this average value for numerical calculations. Okay, that means depending on this factor, few questions are asked in WBCS exam, in CGL exam, in railway exams. So let me give you an example. Suppose that type of question is asked, a body has been moved from equator to pole. How its weight will be changed? That kind of question will be asked. So the answer is very easy. When you move from equator to pole, as g increases, your weight will increase, because weight depends on gravitational pull. So W equal to m into g. That means when you are at equator, WE equal to m into GE. E for equator, or rather EQ I am writing, equator. Acha. When you are at pole, W at P equal to m into G at P. Which one is greater? I already discussed this. G at pole is greater than G at equator. That means which one is greater? WP is greater than W equator. That means weight of a body is greater at pole, less at equator. That means we can say the more the latitude increases, okay, the more will be the value of g. Latitude means the latitude value of equator is 0 degree and at pole it is 90 degree. The more the value of latitude is, the more the value of g is. So if you move from equator to pole, weight of a body increases. That kind of question can be asked. Suppose another question, another example I am giving. Suppose it is asked that the height of troposphere is greater from which surface? First option equator, second option pole, third option both, last option none of this. That kind of question is asked. So what my question is, again I am saying height of the troposphere is greater from which surface? Definitely the answer will be equator. Why? Because what do you mean by height of troposphere? All of you know that troposphere is the bottommost layer of atmosphere, and height of troposphere is greater from equator, because at equator gravitational pull is very less. The less is the gravitational force, the more will be the height, because if somebody is pulling you down, how can you move up? At equator gravitational pull is very less rather than at pole, so that from equator it's very easy for the atmospheric particles to get the height. So that it's very easy for the troposphere to get the height from equator, so that height of troposphere is greater from equator and lesser from pole. And that is a question. Another type of question is whenever any kind of rocket or any kind of space item like space shuttles are launched, where from it is preferable to launch? Answer is definitely equator, because at equator, I know that all of you know that at equator gravitational force is very less, value of g is less, because effect of rotation is very high, centrifugation is very high at equator. So at equator throwing tendency is very high, so that it's very easy to throw any space item from equator, and so that we can say that at equator g is less and throwing force or centrifugal force is high, so that from equator it's preferable to launch any space item. Okay, that kind of basic questions can be asked. One more question I want to give you, that question once was asked in IAS exam. Suppose the question is there is a bear which is fallen from a height of 10 meter. Okay, a bear is fallen from a height of, or it fell from a height of 10 meter, and it took root 2 second time to touch the ground. Okay, I repeat my sentence. Bear fell from a height of 10 meter. It took root 2 second time to touch the ground. What is the color of the bear? That's a very funny question. Okay, once upon a time that question was asked in IAS exam. I repeat my question. There is a bear which fell from a height of 10 meter. It took root 2 second time to touch the ground, and you have to say what is the color of the bear. So the information I am writing on the board. Height of the bear is 10 meter, which is given in the question. Okay, it took how much time? Root 2 second time to touch the ground. You have to say what is the color of the bear. So I am going to write a mathematical formula as h equal to half gt square. H equal to half gt square. That is a mathematical formula, because initially the bear was at rest. Its initial velocity was 0. Initial velocity u was 0. So h equal to half gt square. H equal to 10. That is given in the question. Half into g into t square. T square is given. Root 2 square. Value of g, look, value of g I have not written over here. Why? Because value of g is not given to us. Already I said that there is an average value of g. There is an average value of g. G averaged equal to 9.81 meter per second square. Already I said this, and that also I said that at equator the value of g is less than this, and at pole the value of g is more than this. Okay, so but where the incident takes place we don't know. So where the bear fell or where the bear is fallen, that we don't know. So the value of g we can't put. Okay, so we will find out, or we try to find out the value of g. If we are able to find out the value of g, then only we can say what is the color of the bear. So let's calculate. 10 equal to root 2 square equal to 2. So 2 into 2 will be cancelled out. G, that means g equal to 10 meter per second square. That's our obtained value. Look at this value now. We can say that this value is greater than this value. So 10 meter per second square, which is more than the average value, that means this value of g should be found at pole, because it is greater than the average value, because already I told that the average value of g is 9.81 meter per second square, and the value of g is more at pole, less at equator. Okay, so what we got the value of g as 10, which is more than 9.81 meter per second square. So as the value of g is more than the 9.81 meter per second square, that means the incident takes place at pole. So it must be a polar bear. So polar bear is white. So our answer will be white. So that's a very funny question. Initially when you heard the question from me, you feel as if it's a very funny question, but proper physics is there. Now we will learn Kepler's law. Kepler's law is a very important topic in gravitation. Okay. So what the Kepler's laws are related with? Kepler's laws are related to the planetary motion. What do you know by planetary motion? Planetary motion means all the planets are moving around the sun. So that is what is called planetary motion. So Kepler's laws are valid in planetary motion. Okay. So once upon a time, you know that people knew that in the solar system, Earth is at rest and sun is moving around the Earth, and they named the system as geocentric system. GEO. Okay, geocentric system. Geocentric means Earth is at the center and all the planets, rather sun is also moving around the Earth. But that is wrong. First it was said by Copernicus. Then Mr. Galileo came with his telescope and so many observations. Then Mr. Kepler came. Mr. Kepler gave some mathematical formula, and he gave us 3 laws by which he tried to explain how the planets are moving around the sun. So before, like Copernicus, people knew that the solar system is geocentric. After Copernicus, slowly the people started to know that that is wrong. It should be heliocentric. It is not geocentric, it should be heliocentric. Heliocentric means what? Helio means big central body, which is called sun. The sun is at the center and all the planets are moving around the sun. That is true, and that was first established by the scientist Copernicus. Before Copernicus, the theory was based on geocentric theory. After Copernicus, the theory take a new form called heliocentric theory. So what this theory is, Mr. Kepler gave us 3 laws. I am going to explain this theory by his 3 laws. So Kepler's first law is called law of ellipse. Second law is called law of area, and third law is called law of time period. Law of ellipse, law of area, and law of time period. Okay, these are the 3 laws of Kepler. Now one by one I am going to explain you this. In the first law, Kepler said that all the planets are moving around the sun, keeping the sun at one of the 2 foci, and all the planets are moving in elliptical orbit. All the planets, I repeat my sentence, all the planets are moving around sun in elliptical orbit, keeping the sun at one of the 2 foci. And ellipse has 2 foci, sun is at one focus. Suppose that will be the elliptical orbit. Okay, that is the position of sun, and that is the position of Earth. Okay, Earth is moving around the sun like this. Sun is at one of the 2 foci. Sun is at one of the 2 foci. That is one position of focus. Earth is moving around the sun like this. Okay, so that is what is the first law. First law is giving the idea of elliptical orbit. What about the second law? Second law is called law of area. So as I told that Earth is continuously moving around sun, and the distance between Earth and sun is not fixed. Distance between Earth and sun is variable. Look at this diagram. Sometimes Earth is furthest from sun, sometimes Earth is closest to sun. Okay, so Earth is moving, suppose Earth is moving, that is the diagram. From this point to this point Earth has moved, and an area has been formed. Again Earth is moving. Again Earth came over here and another area forms. Suppose 2 different areas I have shown, A1 and A2. A1 and A2, 2 different areas I have shown. Suppose Earth takes 1 day time to complete this area, and here Earth takes 1 day time to complete this area. So here also Earth takes 1 day time, here also Earth takes 1 day time. In 1 day time Earth takes these 2 areas, A1 and A2. As per the second law of Kepler, A1 is equal to A2. So Mr. Kepler said that the radial separation between sun and Earth covers equal area in equal interval of time. Interval of time is fixed, area is same, A1 equal to A2. That is our second law. And the last law, or the third law of Kepler, the third law of Kepler is the law of time period. here Kepler said that T square is proportional to R cube. T square is proportional to R cube. T is the time period of revolution, R is the average distance or the semi-major axis of this elliptical orbit, or you can say R is the average distance between Sun and the planet. Okay, from this formula definite numerical questions can be asked, just like one demo I am giving. Just like if it is said that this R is representing, already I said that R is representing the average distance and T is the time period of revolution. Okay, so if the question is, suppose the average distance between Sun and Earth is suddenly halved, what will be the length of 1 year? That kind of question can be asked from this formula. So suppose R is said as R becomes R by 2, that means average distance between Sun and Earth becomes half. So what will be the length of 1 year? If that kind of question is asked, generally what is asked in WBCS exam previous years, that is R is given as R by 2, then your T will become T by 2 root 2. If R is given as R by 2, T will become T by 2 root 2. And what is the value of T? 365 days. When you divide it by 2 root 2, it will be approximately 129 days. Approximately it will be 129 days. So that kind of question can be asked, as the average distance between Sun and Earth is halved, what will be the length of 1 year? Average distance of Sun and Earth is doubled, what will be the length of 1 year? That kind of questions are generally asked in WBCS mains exam or prelims exam also.